welcome to this channel. In today's video, I'll define the function and when is the function differentiable, and we'll look at the differentiator from the first principle. Let us first define a function. A function of x or any other quantity is, or any other quantity theta x or t is a quantity the value of which x depends. It is also denoted as f of x. From here, when is a function differentiable? A function is differentiable at x a function is variable at x if and only if the numerator limit x tends to 0 and x plus h minus f of x divided by h exists. Now, let us look at differentiating from the first principle. We were taught gradients from our previous knowledge in SS2, perhaps in SS1, and when we define a gradient, we say that a gradient occurs like this, and it takes the tangent of this point. We call this place x and y axis, and we call this place, let's name this as the curve which is f of x, and we say this is change in y, and call this place change in x. And from there, we mentioned that when there is an increment in x, that is, when there is an increment in y leads to an increment in x. Let's take this example. Y equal to, if y equal to s squared, differentiate y from the first principle. Solution. See, y equal to s squared. Here we say that an increment in y leads also to the corresponding increment in x. That is, y plus change in y is also equals to x plus change in x. Remember there's a square here. Now, if you are to expand this, we will have y plus change in y is equals to x plus change in x squared. We have expanded this, and from here we subtract y from both sides and say change in y resulting x plus delta x plus delta x minus y. From this point, we were given that our y equals to x squared. So we say it's equals to changing y equals to x plus changing x plus changing x minus x squared. Let us expand this. This one results in x squared plus x change in x plus x change in x plus change in x squared minus x squared. Definitely, x squared cancels x squared. So we have change in y is equals to this one result in 2x change in x. Now, dividing both sides by plus theta x squared. Dividing both sides by theta, we have divided by theta x equals to 2x theta x plus theta x squared divided by change in theta. And looking at it very carefully, you can split it as 2x theta x divided by theta x plus this divided by this. This one take this one take this. So we have changing y divided by changing x equals to 2x plus change in x. From here, let us change this to dy ds, changing theta delta y into dy and dx and taking the limits. We have dy dx equals to limit changing x tends to 0 is equals to 2x plus change in x, and we now have dy dx equals to 2x. From here, we can also say that the x squared or the x squared dx equal to 2x. Let's consider example 2. If y equals to x raised to the power 3 minus 3, x raised to the power 2 plus 3. Differentiate y from the first principle. Solution. We say that while differentiating this, an increment in x results also in an increment in y. And we have y equals to x squared plus 3. And we now say 1 plus change in y equals to x squared plus 3, or we say x plus change in x squared plus 3. Now, when we expand this equation, we will have, by expansion, we will have y plus change in y is equals to x plus change in x, x plus change in x plus 3. And this all results in y plus change in y equals to x squared plus 2x change in x plus change in x squared plus 3. Remember, from the equation, we have to take this and we have change in y equals to x squared plus 2x beta x squared plus 3 minus y. Remember that our y from the equation is x raised to the power 2 plus 3. So we say that y equals to x squared plus 2x beta x plus beta x squared plus 3 minus this, which is x squared plus 3. Definitely, here is like this, and here we have a negative sign before the bracket changes to x squared plus 2x beta x plus beta x squared plus 3 minus x squared minus 3. Definitely this one erases this one, plus 3 cancels minus 3. And from there we have change, that is delta y equals to 2x beta x plus beta x squared. And here now we will divide it by beta x, and that results in changing y, changing x, resulting 2x plus square, all divided by changing y. My dear viewer, hope you are following. From here, we can say that this one results in 2x changing x over changing x plus changing x squared over changing x. This one take this, this one take this. So we have changing y over changing x equals to 2x plus change in x is the next line of action. What we are going to do next is we take the limit of both sides, that is changing divide to divide x and taking the limit. What is a limit? Limits are simply boundaries. The boundaries at which our values must be, like upper boundary, lower boundary, form like that. So here we now have dydx equals to limit changing x tends to 0 2x plus change in x plus change in x. And finally, say dy dx equals to 2x, or d x squared plus 3 dx equals to 2x. I would like you to practice these two questions. Perhaps you have questions to ask me. You can easily write the question. If y equals to 3x squared plus 5x, find the derivative from the first principle. 2. Find dy dx if y equals to x is power 3 plus 2x power 3 minus 5x plus 1 from the first principle. You can comment below if you have questions pertaining the ways by which you can solve these two questions. Thank you.